Okay, so we've been doing the derivative in calculus by differentiation. And so now we're going to look at how we use it in an example. So when you see this function here, f of x equals x cubed minus 2x squared plus x, and they ask to find the stationary points. What do we need to do to find the stationary points? Okay, we need to find the derivative first, which is our f dash of x, or sometimes written in your course as dy over dx. And then to find the stationary points, we make that equal to 0. Because remember, on a function, this is a cubic function, our stationary points are over here and over here, right? There's your max and your min. And so those are where your f dash of x is 0, because there's no slope. If we were to do a tangent, there would be no slope. So the stationary points, as soon as you hear stationary points, you know we have to find the derivative and make it equal to 0. Now, the nature of those points is whether it's a maximum or a minimum. So when you want to find out, is it a maximum or minimum, you find the derivative of the derivative. In other words, the second derivative, f double dash of x. Okay, and that's going to tell you whether it's a maximum or a minimum. So a max would be here, and a min would be here, the minimum value. And so you find your f double dash. Now your minimum is where your f double dash of x, a smiley face graph, right? So happy. So it's where your f double dash of x is greater than 0. Where you have a maximum, you have a sad face graph. So f double dash is sad. So if you're sad, you are negative, right? So then it's f double dash of x is less than 0. Okay, so we're going to first find the derivative. Okay, and we can do that by saying f of x, f dash of x is 3x squared. If you don't know how to do that, you'll have to look at the introductory video. 2 times minus 2 is minus 4x. And the derivative of x is just 1. Okay. So you should know how to do this. If you don't, I'll just link to the video where you learn how to do that. Now we make it equal to 0. And then we just solve. So we know we're going to have factors of 3x. So that'll be 3x and x. And we need to get a minus 4. So this is going to be then, because it's a positive, because we've got a minus in the middle, but a positive at the end, we know we have a negative and a negative, because negative times negative is positive. And you can see when we multiply this out, we will get negative 3x minus x, which would be minus 4x. So that's done. And now we solve. So we get 3x equals 1. Actually, let me not skip. So we have 3x minus 1 is equal to 0, or x minus 1 is equal to 0. So we now take the 1 across, and then we have x. We divide by both sides by 3 to get rid of the 3, and here we have x equals 1. Okay, so those are going to be the x values of our minimum and our maximum. Now to get our y values, we just simply sub those values into the original. So we'll have 3. So let's do the first one. So I'll do this one in yellow. So, and we sub it into the original, right? Because it lies on the original graph. So the minimum or the maximum in yellow, I've now changed it to yellow. If I put the x value into here, it would actually tell me, well, what would y be on this function? So I have to substitute into the original. Okay, some people make the mistake of substituting a third back into this one, into the derivative. Now, if you sub a third back in, you're going to get 0 because you've solved it already, and you got a third was when it was 0. So if you were to sub a third back in here into this one, if you were to sub a third back in here, you would get 0, which is obviously not the answer. Well, it could be the answer, but it shouldn't be. 3, a third square. I started to actually sub it and do what I said not to do. Okay, a third cubed minus 2, a third squared plus a third. Okay, so we get 1 over 27. Yeah, you can put this in your calculator. 2 times 1 over 9, 2/9 plus a third. Okay, now we're going back to GCSE maths, and maybe even before then when we learned how to add fractions. So stage 7. So we're going to get them both to everything over 27. Okay, you don't have to do all this. You've got a calculator. I'm just doing it. 6 and 9. Okay, so you get 1 plus 9 is 10 minus 6 is 4. So we get 4 over 27. So our one value is a third. And so one of our stationary points is a third and 4 over 27. Liam, did you get that?
Yeah.
Okay. Now, let's do the other one in green. Okay, so now we'll do f of 1. It's going to be easier. So we have 1 cubed minus 2 times 1 squared plus 1. So here we end up, we actually do get 0, which is fine. So if we had substituted the 1 back into the original, we would still get 0. We would have got 0. We would have actually got the right answer for this one, but with the wrong method. So you wouldn't have got the marks. But here we get 0. So our other point is 1 and 0. So that's why I said you sometimes can get the right answer if you sub it back in here, because it is possible that our turning point is also on the x-axis. So what we're probably looking at is something like this, where we have a point here where the turning point is on the x-axis. Okay, now we want to find out the nature of these stationary points. So we find the second derivative. Okay, so we're doing that in pink with the stationary points. So let's just put those in pink. And we highlighted this in blue. So we're going to do the nature of those points in light blue, just to separate it. So f double dash of x, we find the derivative of the derivative. So 2 times 3 is 6x, because we take 1 of the 2, and then minus 4. Okay, so now this is the double derivative. So what we do now is we sub in our x values into here. And if it's positive, we know that it's a happy face graph, meaning you'll have a minimum. Or if it's negative, it's a sad face, so a maximum. So F double dash, we'll do the first one as a third. So I'm going to do that in yellow just so that we are seeing, you're seeing which one I'm putting in. So we're doing that one in yellow, 6, and then a third, minus 4. We get a negative value. The 6, we get 2 minus 4, so we get negative 2. Okay, what's important is not the value, the 2, but the sign, minus. So we know it's essentially a sad face. So this will be a max. You have a maximum. Now we'll do F double dash of the other one, which is 1. And we get 6 times 1. And here we get a 2. So this is a concave up, so that will be the max. Minimum, sorry. So this function actually, Lev, did you get the same?
Yes, I think I did.
Okay, so now we've got our, so now we've got we would simply just write out our answer. The stationary point here, a third and 4 over 27 is a max. And then 2 is a min. Okay, and when we look at this function, it makes sense because our maximum over here would kind of be over here, which would be a third. And 4 over 27. And then the other one, when I said it probably looks like something like that, well, yes, it does, because our minimum here would be 1 and 0. Okay, and if I was to do the y, what's the y-intercept? Is a third, right? Y-intercept is 1. So yeah, your y-axis is going to be about there, and so that's 1 over there. Oh no, so yeah. The x-intercept is 0, the y-intercept is 0 because there's no d here. There's no number by itself. So if you made if you put a 0 for x in the function, if you replace the x's in the function with 0, you would get 0. So actually our function that you have to draw it out, but our function is going to look like that. Okay, so the y-axis is over here. Okay, so that is your answer. So the nature of the points, it tells you whether it's a maximum or minimum. We've done that, and we've gotten our stationary points.